I'm Robert Odell. You see me in such fine quality, epic chemistry videos such as Redox Equations are for Losers of Electrons, Part 2, and Oxidation Reduction? Who needs that for human survival? Alright, remember we worked on a problem in class looking at the chromium ion plus ozone getting us bromide oxide, and then we got ozone out of that way. This is not right. I know I made a mistake here somewhere. Hold on. Okay. This is what happens when there we go. Now I feel much better about that. We talked about the idea about how in the world do we balance this in a basic solution. Okay? And this is where we start to get a little bit confused on some of the stuff, where to go, and I spent a bunch of time trying to work with this out here. Now I wrote it down on this leftover flyer from Biology Day. So we're going to go and we're going to break this into our half reactions. Okay? So remember, in the half reactions, the idea is we're looking at what's happening. We're talking about what's happening here with just one part of the reaction. And in this case here, we're emphasizing on our chromium ion. Okay? Now when we look at the chromium ion, we kind of notice, okay, what are the oxidation charges on here? Well, if we look here, we have that minus sign, so we know that the chromium here has a -1 charge. Now, what about this side? Well, according to remember those oxidation rules, you have oxygen with a -2 charge to it. And wait a minute, the whole thing here, this entire thing is a -1. So if you think about it, okay, we know this is a -2, so if we plug in the algebra, x -2 is equal to -1. Well, what does that mean? That means that our bromine has to be a +1 charge. Now, hold on a second. To go from bromium of -1 to a bromium of +1, that means something had to happen with the electrons in order to make that work. What happened? Well, at this point, it would be a safe bet to say 2 electrons were kicked out, okay, to make this from a -1 to a +1. So, with that, we can turn around and say, all right, that's what we have. That's the beginning for us. But we also have to realize that we have an oxygen on this side here. How in the world do we balance that? Well, we're going to add H2O here, okay, to take into account the oxygens there. But we also, now that we've got our oxygens, our bromines are balanced, our oxygens are balanced, but not the hydrogens. So that means we're going to have to add another thing. So here's H2O plus Br minus gets us our chromium oxide, or BrO, plus 2 electrons, plus now we have to add our hydrogen ions in there to take into account these 2 hydrogen atoms here in this water. We had to add this water because we had to balance out the oxygen. That was on this side, because remember, think about math, what happens on one side of the equal sign has to happen on the other. So that's what we've got. Now, okay, great, except now, how are we going to take care of the OA, of the H's here? Well, we have to add, because it's in a basic solution, we have to add OH minus. But again, what you do to one side of the equal sign, you have to do it on the other. So in this case here, we're going to have 2OH minus plus H2O plus Br minus. It gets us our BrO ion plus 2 electrons plus 2H pluses plus 2OH minus. Okay, and at this point now it looks like it's balanced out. What we need to do though is we have to figure that the H and the OH, they're going to attract each other. Why? Because they're opposites, and you guys might remember Paula Abdul, opposites attract, way back when. So let's go ahead. I'm going to write this out in blue. So we have 2OH minus plus H2O. I am rewriting the whole equation step by step so you guys can see this. BrO minus plus 2 electrons plus 2 H2O. What did I do? I took the 2H and the 2OH, combined it into the 2H2O process. So now, if we look at the whole thing, you may notice we have a water on this side, we have two waters on this side. So that means this will cancel out with one of these. So what's going to be our final balanced half reaction? We have got 2OH minus plus BR minus, okay, gets us our BrO ion plus 2 electrons plus H2O. So that's the balanced part, ladies and gentlemen, for our first thing here. And pretty much, I would say you guys were pretty good on that part. Now, what about the second part? Okay, what about the second part? Okay, and here's the second part. We looked at the second half of the equation, O3 going into O2. Here's where we made our mistake. And I should say because I sat down and said, hey, these don't have charges to them, which is correct. This is elemental oxygen. You find it in nature. You also find it here, so the charges there are going to be 0. Okay? However, here's the thing though. This side is missing an oxygen. The only way we can balance that out, we have to add a water to it. So what that does, that gets us, O3 gets us O2 plus H2O. Now we have balanced out the number of oxygens on this side by adding the water to it. However, now we have these extra hydrogen ions floating around. Where are we going to be adding those? Well, we're going to go ahead and add 2 hydrogen ions on this side, plus O3 gets us O2 plus H2O. Woo! Okay. So now we're good. We've got our oxygens taken care of. We have our hydrogens taken care of. However, this is a basic solution. So guess what? We got to add the OH to take this out. Okay, so we're going to have to go with 2OH. Now remember, the idea is to balance out this plus 2H plus O3 gets us O2 plus H2O. And remember, what you do to one side of the equal sign, like in math, we got to do it over here as well. Okay? So that's what we have here. Okay? So, all right, everything looks good, but now we need to do a little bit of combinations, don't we? Okay? So we're going to go ahead and we're going to say, okay, 2H2O plus O3 gets us O2 plus H2O plus 2OH minus. So we're going through that process, we're balancing it out. I just combined this to form water because, again, opposites attract via Paula Abdul. Okay, and now what can we say here? Well, we got water on this side, water on this side. Guess what? We can do some more canceling out. I bet you that's making you feel good. Okay, canceling this out, we can call this the Odell Effect. Yeah, we'll call it the Odell Effect. Okay, so H2O plus O3 gets us O2 plus 2OH minus. Okay, now, here's the key. You'd say, but wait a minute, the oxygens, they didn't lose electrons, they didn't gain electrons. You're right, they didn't. But we do run into a problem though, and that is we have got a total negative charge here. Where's that negative charge coming from? Well, we got these 2OH minuses, so we have 2 of them. Guess what? We're going to have to balance that out on this side. The only way we will balance it out on this side is adding 2 electrons. Oh yeah. So we're going to have here, we're going to add 2 electrons plus H2O plus O3 gets us O2 plus 2OH minus. Okay, so this is now our balanced half equation. Okay, we have that. We also have our balanced half equation from the first half. Okay, Now we got to combine the whole thing together. This is where I'm going to have to write small. So for those people who are squinting, please, it's okay. So 2 electrons plus H2O plus O3 plus 2OH, okay, plus Br minus, and we get the arrow that says, and we're going to have to do it on this side here. In fact, I'll do it in red, okay, O2 plus 2OH plus BrO. Yeah, bro, don't tase me, bro. Plus 2 electrons and plus H2O. Okay? Now, I am filming in the presence of honors chem guys, and it's the beginning of the year, so for them, they're kind of lost in the language at the moment. They're not there yet, and that's okay. Now that we have that, what did we do? We took our 2 half reactions, our balanced half reactions. We took this one, and we took this one, and then we combined them together down here. That's all I did. Now it's time to do the final countdown. The final countdown! Okay, let's do it. What do we have here for our final countdown? Well, we got 2 electrons on opposite sides of the arrow. They get canceled out. Bam! All right, guess what? We got an H2Os here. 1 on each side, right? Is that correct? Yep, we do. And that gets canceled out. Bam! All right, now we got 2 H's, 2 OH's. Oh, guess what? They're on opposite sides of the arrow too. Now they cancel each other out. Bam! Now, let's write this out here. O3 plus Br with a minus gets us O2 plus BrO. Don't tase me, bro. And this is it. This is our final balanced redox equation. And you're sitting there saying, wait, Mr. Canu, isn't that the original equation that you had at the beginning of this problem? Yes. Yes. Wait, we came around this entire circle for nothing? No. You proved that it is in fact balanced as it is. We went through a whole bunch of series, doing all these calculations, balancing out the atoms, balancing out the electrical charges, the negative and positive charges of this whole thing. This is it. We're done. So, I'm hoping that this will help you guys out. And this is Robert Odell signing off. I'm off to 5 nights at Canu's. Woo!